Let's take a look at motions of the Earth. There are two basic motions to be aware of. The first is the rotation of the Earth on its own axis. The Earth's axis, of course, runs through the North and the South Pole, as you see in the picture here. And the axis is shown here as being tilted, like the Earth is on a wobble. So if you think of the Earth's elliptical plane and compare it to the orientation of the Earth's pole, there's a difference, there's an angle there that is 23 degrees 27 minutes, or if you convert that to decimal degrees, it's 23.5 degrees. So that is the tilt of the Earth's axis. So the first rotation, or the first motion of the Earth, as I mentioned, is rotation. The second motion is the Earth's orbit around the Sun, which is an ellipse. The Sun is one of the focus points, or foci, of the ellipse. Here it's exaggerated, but you get the idea, hopefully, that the Sun is not exactly the center of a circle. The Sun is a focus point of an ellipse. So as the Earth travels around the Sun, there are 4 dates that are important. We'll start here with the vernal equinox, which is also the spring equinox. It occurs in March, around March 21st. Sometimes it's right on the 21st, but it's usually right around that date. On the vernal equinox, the Earth's orientation to the Sun is such that all locations are receiving 12 hours of day and 12 hours of night. The Sun is going to be directly overhead the equator at that time of the year. As we move into the summer solstice, you can see that the Earth's orientation to the Sun is such that the North Pole is facing towards the Sun, which means that it's summertime in the Northern Hemisphere. Days are longer than nights for the Northern Hemisphere, just the opposite for the Southern Hemisphere. Here, the latitude that is receiving direct solar radiation, where the solar altitude is directly overhead, is 23.5 degrees north latitude, as we'll see in a moment. The next important date is the autumnal equinox, which occurs around September 23rd. Just like the vernal equinox, all locations on the Earth receive 12 hours of day, 12 hours of dark, and the Sun is directly overhead at the equator. And finally, we have the winter solstice, which occurs around December 21st. Now the South Pole is oriented towards the Sun, so we have longer days in the Southern Hemisphere and longer nights in the Northern Hemisphere. Equinox literally means equal night. And if we look at the circle of illumination, as you see here, you can see that it divides the Earth into equal parts of daylight and nighttime. If you think of the Earth rotating around its axis, we have equal day and equal night for all locations on the Earth. For the 2 equinox dates, the Sun is directly overhead at the equator. For the Northern Hemisphere summer solstice, we see that the North Pole is tilted towards the Sun, and the circle of illumination clearly shows that the North Pole the North Hemisphere is getting more sunlight than the Southern Hemisphere. The Sun is going to be directly overhead at latitude 23.5 degrees north, which is this dashed line here, and that latitude has a special name. It's called the Tropic of Cancer, 23.5 degrees north latitude. The Arctic Circle is another latitude of importance. It's located at 66.6 degrees north latitude, and the Arctic Circle defines the zone northwards of which locations will receive 24 hours daylight during the summer solstice, or during the summertime in the Northern Hemisphere. So it defines the period of, or the locations that receive daylight for 24 hours. Similarly, in the Southern Hemisphere, the Antarctic Circle, which is at 66.6 degrees south latitude, defines locations for which there will be 24 hours of darkness on this day, which is the Northern Hemisphere southern solstice. So you can see the circle of illumination touches those places, casting the Arctic Circle in daylight and the Antarctic Circle in night light. You can see the number of day length is greater for the northern hemisphere in positions that are located further north, and the day length decreases as we move towards the South Pole. Just the opposite on the northern hemisphere winter solstice. Now the South Pole is facing towards the sun, and the sun is going to be directly overhead 23.5 degrees south latitude, which has a special name. This latitude is called the Tropic of Capricorn. And we have summer in the South Pole, in the southern hemisphere. So the Antarctic Circle now defines locations that receive 24 hours of daylight, and the Arctic Circle defines locations that receive 24 hours of nighttime. And we have longer days at the South Pole, and they become shorter as we move towards the North Pole. If you look at the path of the sun at different locations for different times of the year, starting at the equator, we see that the sun will be directly overhead on the equinox days, March 21st and September 23rd, thereabouts. If we look at the summer solstice, we see that the sun has moved further north in the sky. It's still very high in the sky. And on the winter solstice, we see that the sun has moved further towards the southern sky. For a mid-latitude location, which we're more familiar with, for the summer solstice, this is when the sun will be the highest it's going to be in the sky. So if you go outside on the summer solstice this year around noon and look at where the sun is, that's the highest position, that's the furthest north that it's going to be in the sky throughout the year. For December 21st, the winter solstice, that's when the sun will be the lowest at noon in the sky. And then for the equinoxes, it's right in between there. So the sun's location is going to be relatively contained within this band of elevations. And then for the North Pole, we have a situation on the summer solstice where the sun is going to be visible for 24 hours a day. And it won't be very high in the sky, but it will make its way all the way around the sky. Same thing for the equinoxes, except for the sun won't be very high at all. It's just going to be right on the horizon, like a constant sunrise or sunset as it circumnavigates the horizon. And then all locations in between will receive the same kind of treatment in the summertime, and we don't see the sun at all for the winter solstice. Before having an understanding of how the Earth's location and its orbit around the sun affects the seasons, it's kind of typical for people to think that seasons are caused by how close or how far the Earth is to the sun in its orbit. This graphic shows the position of the sun, or the position of the Earth rather, relative to the sun at its closest and farthest points. When it's at its closest point, this is called perihelion, closest to the sun. It happens on January 3rd, which is our northern hemisphere summertime. So clearly, when the Earth is closest to the sun, it does not mean that it's going to be hotter. Similarly, when the Earth is furthest in its orbit from the sun, that position is called aphelion. It happens around July 4th, which is our summertime, and this is not the coldest time of the year. So aphelion and perihelion are important positions of the Earth in its orbit around the sun, but they do not dictate the seasons on the Earth. This graph shows the duration of daylight for different locations on the planet that move from the poles to the equator. So across the x-axis we have the month of the year, and on the y-axis we have the number of hours of daylight. And then you can see the different periods, the equinoxes and solstices. So the curve with the most extreme arch is Edmonton, which is in Canada. It's very far north, 54 degrees north. And you can see that it has almost 17 hours of daylight on the summer solstice. And then on the winter solstice, which is over here, it has just about 7. So it goes from 17 to 7. It's a huge variation. As we move a little closer towards the towards the equator and look at Denver, we see a similar curve, but not as extreme. So we're still receiving longer days during the summer than we are during the winter, but not as extreme as for Canada. And we see that the pattern continues until we look at a location that's close to the equator, Caracas, Venezuela, which is at 11 degrees north. And you can see that the hours of daylight don't really fluctuate that much throughout the year. They're between 11 and 12, just a little bit more throughout the year. So the number of hours of daylight vary based on latitude.